Welcome to Brain Vision.
Hello everyone, as shown in the figure, a 4 kg rod AB and of length 720 millimeter, that is 0.72 meter, attached to the collar having negligible mass at A and the flywheel B. The mass of the flywheel is 16 kg and its radius of gyration is 180 mm, that is 0.18 meter. As shown in the figure, at this position, its angular velocity is 60 rpm or 2 pi radian per second in clockwise direction. We have to calculate velocity of the flywheel. When point V is directly below C, this is C point, I am marking with blue color. So, we have to find the velocity of flywheel when point V is directly below C. Let us see here. Moment of inertia of the rod AB about its centroid will be 1 by 12 mass of AB calculating its value. Mass is given 4 kg, length is 0.72. So its moment of inertia about its centroid would be 0.1728 kg meter square. Moment of inertia of the flywheel we are marking FW, or you can also mark IC. So we can write MC. It will be MC into K square. Substitute the value. Mass is given 16 kg. Radius of gyration is 0.18. So you will get moment of inertia of flywheel is 0.5184 kg meter square. Now at position 1, angular velocity is omega 1 in clockwise direction. See the geometrical view. This is the flywheel, omega 1. This is the rod AB. VA. This is centroid having the velocity in upward direction. This angle is beta, and this is A point. And this we are considering to be H1. So angle beta, sine of beta can be given by 0.24 upon 0.72. So beta will be 19.471 degree. H1 will be half of 0.72 cos of beta, that is cos of 19.471. So its value will be 0.33941 meter. So gravitational potential energy of rod AB, you will get weight of AB into H1, 4 into 9.81 into 0.33941, that is 13.3185 joule. Velocity of V point will be R into omega 1, where AB is in translatory motion. So omega AB is 0. Velocity of centroid will be velocity of V point. So total kinetic energy of the system is half m AB square, half I AB omega square AB plus half IC omega 1 square. Substituting the value, mass of the rod AB is 4 kg. Its velocity is 0.24 omega 1. Omega AB is 0. IC moment of inertia of the wheel 0.5184 into omega 1 square. So total kinetic energy we will get 0.3744 omega 1 square. Position 2. In which B point is just directly below the C. So you can draw the diagram here. This is velocity of V, centroid A omega 2. So in this case, H2 will be half NAV minus R 0.72 minus 0.24, that is 0.12 meter. So potential energy in second position, mass of AV into G into H2, so 4 into 9.81, so you will get 4.7088 joule. Now kinematics, velocity of V point R into omega 2, that is 0.24 omega 2. Velocity of rod AV, angular velocity of rod AV, velocity of V divided by 0.72, that is 0.24 omega 2 upon 0.72, that is 0.333 omega 2. So velocity of centroid of the rod, half of velocity of V, that is 0.12 omega 2. So total kinetic energy in position second, half mass of AV into velocity of centroid, half AV omega AV square plus half IC into omega 2 square. Substituting the value, all parameters are known to us. Mass of rod AV is 4 kg. Velocity we have estimated 0.12 omega 2 square. Moment of inertia of rod AV is 0.1728 and its angular velocity is 0.333 omega 2 square. Moment of inertia of the flywheel 0.5184 into omega 2 square. On solving it, you will get 0.2976 omega 2 square. Applying conservation of energy, T1 V1 is equal to T2 V2. Substituting the value, initial kinetic energy is 0.3744 into omega 1 square. Potential energy is 13.3185. Kinetic energy in second position 0.2976 omega 2 square plus potential energy in second position. Omega 1 is given 2 pi, substituting and finding omega 2. So 2 pi square (13.3185) minus 4.7088 divided by 0.2976 omega 2 square. So angular velocity omega 2 we will get 8.8655 radian per second. That is the answer for this problem. Thanks for watching it.